When installing electrical metallic tubing, also known as EMT, prioritizing a plumb installation is paramount. The fundamental purpose of EMT is to provide robust mechanical protection for the electrical conductors it houses. A plumb installation, meaning perfectly vertical, contributes significantly to the overall structural integrity of the conduit run. Firstly, a plumb EMT run distributes weight and stress evenly along its length. This is crucial for resisting bending or deformation caused by external forces, such as impacts, vibrations, or even the weight of the conduit itself, especially in long vertical runs. Secondly, a non-plumb or tilted EMT run concentrates stress at specific points. This uneven stress distribution weakens the conduit system and makes it more susceptible to damage. Thirdly, consider the effects of gravity. A plumb conduit is aligned with the gravitational force, minimizing strain. A tilted conduit experiences a shear force component which can gradually cause the joints to loosen or the conduit to bend over time. Fourthly, a plumb installation simplifies the process of securing the EMT to the supporting structure. Standard conduit clamps and supports are designed to work optimally with plumb runs. When the conduit is not plumb, additional shimming or custom modifications may be necessary to achieve a secure attachment. This increases installation time and complexity and potentially compromises the strength of the support. Fifthly, proper grounding and bonding are essential for electrical safety. A plumb EMT run facilitates effective grounding by ensuring continuous metal-to-metal contact between conduit sections and grounding hardware. Sixthly, when the conduit is plumb, standard fittings and connectors will align properly, creating a tight and reliable connection. This tight connection is crucial for maintaining a low impedance ground path, which is necessary for safely carrying fault current back to the source in the event of a ground fault. Seventhly, from a code compliance perspective, the National Electrical Code, or NEC, emphasizes the importance of installing electrical systems in a neat and workmanlike manner, NEC Section 110.12. While the NEC does not explicitly mandate that EMT must be perfectly plumb, a plumb installation generally reflects a higher level of workmanship and attention to detail. Eighthly, plumb installations facilitate future modifications or additions to the electrical system. It provides a consistent and predictable framework for routing new conduit runs or making connections to existing ones. Ninthly, a plumb conduit run reduces the risk of water accumulation inside the conduit. Water can enter the conduit system through condensation or leaks and can cause corrosion and damage to the conductors. A plumb conduit allows water to drain properly, preventing it from pooling and causing problems. Tenthly, consider the long-term maintenance and reliability of the electrical system. A plumb installation is less likely to develop problems over time, reducing the need for costly repairs or replacements. 11thly, in contrast, prioritizing aesthetics by matching the existing pipes to create a parallel appearance compromises the structural integrity and protective function of the EMT. While a visually appealing installation may be desirable, it should never come at the expense of safety and functionality. 12thly, if the existing pipes are not plumb, attempting to match them will result in a similarly flawed installation. This means that the new conduit run will also be subjected to uneven stress distribution, weakened support, and potential grounding issues. 13thly, in addition to the structural and safety considerations, a non-plumb installation can also create problems with the routing of conductors. When the conduit is not straight, it can be more difficult to pull wires through it. This increases the risk of damaging the conductors or exceeding the maximum fill capacity of the conduit. 14thly, the NEC specifies the maximum number of conductors that can be installed in a conduit of a given size, NEC Chapter 9, Table 1. These fill limitations are designed to prevent overheating and ensure that the conductors can be easily accessed for maintenance or repairs. A non-plumb installation can reduce the effective cross-sectional area of the conduit, making it more difficult to comply with these fill requirements. 15thly, another consideration is the potential for corrosion. When EMT is exposed to moisture or corrosive environments, it is important to protect it with a suitable coating or finish. A plumb installation makes it easier to apply these protective coatings evenly, ensuring that all surfaces are adequately protected. 16thly, the type of fittings and connectors used can also affect the overall strength and reliability of the EMT system. It is important to use fittings that are specifically designed for EMT and that are properly sized for the conduit being used. 17thly, when connecting EMT to boxes or enclosures, it is important to ensure that the connections are tight and secure. Loose connections can create a fire hazard by allowing arcing or sparking to occur. 18thly, the supports used to secure the EMT to the building structure should be spaced according to the NEC requirements, NEC section 358.30. These support requirements are designed to prevent the conduit from sagging or vibrating, which can damage the conductors or create noise. 19thly, when installing EMT in damp or wet locations, it is important to use watertight fittings and connectors. This will prevent water from entering the conduit system and causing corrosion or electrical shorts. 20thly, it is important to inspect the EMT system regularly for any signs of damage or corrosion. Any damaged or corroded sections of conduit should be replaced immediately. 21stly, remember that electrical work should always be performed by qualified personnel who are familiar with the NEC and local electrical codes. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. 22ndly, the selection of EMT size is crucial. The NEC dictates conduit fill requirements based on conductor size and quantity, NEC Chapter 9. Using a conduit size too small can lead to insulation damage during wire pulling due to friction, potentially causing shorts or ground faults. 23rdly, the proper bending of EMT is essential for maintaining its structural integrity. Avoid sharp bends that can weaken the conduit and make wire pulling difficult. Use conduit benders designed for EMT to achieve smooth, code-compliant bends. 24thly, when cutting EMT, use a proper cutting tool to ensure a clean, square cut. Dever the cut end to remove any sharp edges that could damage conductor insulation during wire pulling. 25thly, consider using conduit bodies such as LB, LL, or LR fittings to make changes in direction or to provide access to conductors for pulling or maintenance. Ensure these fittings are properly sized and installed according to the manufacturer's instructions. 26thly, when running EMT in concealed spaces such as walls or ceilings, protect it from physical damage by using nail plates or other protective measures where necessary. 27thly, ensure that all EMT fittings and connectors are properly tightened to provide a secure and electrically continuous connection. Use appropriate tools, such as wrenches or pliers, to tighten the fittings to the manufacturer's recommended torque. 28thly, when installing EMT in areas subject to physical damage, consider using rigid metal conduit, also known as RMC, or intermediate metal conduit, also known as IMC, which offer greater protection. 29thly, before energizing any electrical circuit, thoroughly inspect the EMT system to ensure that all connections are tight, all supports are properly installed, and there are no signs of damage or corrosion. 30thly, always follow lockout/tagout procedures when working on or near energized electrical equipment to prevent accidental energization. 31stly, use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools, when working with electricity. 32ndly, be aware of the potential hazards associated with working near energized electrical equipment, such as electric shock, arc flash, and arc blast. 33rdly, if you are not comfortable working with electricity, hire a qualified electrician to perform the work. 34thly, it is crucial to understand local amendments and interpretations of the NEC. These local regulations may impose additional requirements or restrictions on EMT installations. 35thly, consider the environmental conditions to which the EMT will be exposed. In corrosive environments, use EMT with a corrosion-resistant coating or consider using non-metallic conduit. 36thly, when installing EMT underground, use direct burial rated conduit and fittings. Ensure that the conduit is buried at the proper depth to protect it from physical damage. 37thly, when running EMT through fire-rated walls or floors, use fire stop sealant to maintain the integrity of the fire barrier. 38thly, when connecting EMT to equipment with different grounding requirements, follow the NEC guidelines for bonding and grounding to ensure proper electrical safety. 39thly, when installing EMT in hazardous locations, use explosion-proof conduit and fittings that are listed for the specific hazard. 40thly, remember that electrical codes and standards are constantly evolving. Stay up to date on the latest requirements by attending training courses or consulting with qualified electrical professionals.